I have the privilege of welcoming you all to our this flagship, very important webinar on initiatives for expansion of nuclear power generation. We are privileged and honored with the presence of the BC Pathak, CMD NPCIL, and Mr. Andre, CEO of Rosastorm. We are honored with the presence of Dr. Kakodkar, who has been our guide and teacher in India Energy Forum for the last 20 years. In fact, he piloted the nuclear group and took it forward. Nuclear power is a renewable source of energy, fully recognized now. Unfortunately, the country has not been able to add sufficient generating capacity out of the present total installed capacity due to various reasons. The 700 megawatt units indigenously developed are acquiring a very predominant place in enlarging the nuclear generating capacity of the country. Indigenous 700 megawatt units developed are acquiring a major place in the expansion of nuclear capacity. And as I said, now that nuclear is being given a push as a renewable energy, it should acquire a very predominant place. And in the years to come, we will see its further enlargement in the total share of the generating capacity of the country. NPCIL is a world-known organization, very competent, has produced the world's renowned nuclear engineers, and we have total recognition in the world. The biggest project, Kudamkulam, is 6 units, with 6 units is under construction. First units have been commissioned, and Rosastorm has been supporting the efforts of the country and Nuclear Power Corporation to enlarge this capacity. I would like to share some few statistics about the power sector. Power sector is on the growth path. A few days back, Minister of Power gave certain statistics for the last 8 years. In the last 8 years, we have added a capacity of 169,110 megawatts, taking to the total generating capacity of 400 gigawatts, whereas the maximum demand till date is about 215 gigawatts. Very impressive. In the last 8 years, we have added additional capacity of about 170,000 megawatts. As I said, India Energy Forum has been organizing webinars on various verticals of the power sector and has been giving its recommendation. And they have really proven in the status released by the minister. In the last 8 years, we have added 166,080 circuit kilometers of transmission lines. The Indian grid has now emerged as the largest integrated grid in the world. The inter-regional transfer capacity in 2014 was about 36,000, which has been increased to 112,000 megawatts. A lot of work has been done to electrify the villages, and we have a total of 2.86 crores of houses have been connected. They are being given power for 21 days in a year, 21 days in a day. The target of adding the renewable energy of 175,000 megawatt by 2020 has been achieved. We have added 158 gigawatts of renewable energy and 54 gigawatt is under construction. Our target of having a renewable capacity of 5 megawatts, we are pledged to achieve that figure, even though it's some, but 2030, we hope that total generating capacity of the renewables will be, and in that, nuclear will require a good position. These statistics release give satisfaction that the power sector is on the move, and a lot of reforms have been done in the transmission sector. A lot of discoms have promised to improve the ATSC losses. And once that is achieved, the health of the public power sector will be much, much more stronger and better. Let me now say a few words about the India Energy Forum. India Energy Forum was set up in 2001. India Energy Forum is a registered NGO, non-for-profit, not for promoting any individual interest. It has a mission to help evolve a national energy policy aimed at development of a sustainable and competitive energy sector in India. It is probably the only organization which champions the cause of total energy. As I mentioned, we have various verticals in our executive committee, and we are holding webinars on each vertical of the power sector. All forms of energy ranging from coal, power, thermal, hydro, oil and gas, nuclear, renewables. Right from the day of functioning, we have been addressing all the verticals of the. We subsequently added transmission, we added a regulatory framework. This feature of us is a distinct advantage of taking an integrated look on the energy scene. We have more than 120 members from various sectors of our sector, highly experienced and having held very top positions in their career. We are therefore a think tank with inputs from all our members, and we formulate our policies, we formulate our documents, taking their experience and then sharing with the government on the policy issues. Our objective is also serve as independent, as I said, advocate of the industry, promoting practical solutions to issues affecting sustainable development of energy sector, work with other organizations, companies to achieve consensus on such regulatory structure. In this regard, we have signed MOU with International Solar Alliance to promote development of solar energy not only in India but throughout the world. The MOU was signed by Mr. Sahi on behalf of India Energy Forum and Mr. Ajay Mathur on behalf of International Solar Alliance. Prior to COVID, India Energy Forum was organizing physical summits every year on each vertical of the energy sector. Our summits were very, very successful, well received by the delegates, and they were very responsive. For nuclear, as I mentioned, we had the guidance support of Dr. Kakotkar, who steered through the webinars, program steers summits on nuclear program. He has been our guide, philosopher, and associated for a long time. After the COVID, the new team, after Mr. Razdan, who was, anyway, we had a founder president, Mr. P. Bami, former CMD NTPC. He was quite for a long time, gave I would say, a path to India energy sector, a vision to India energy sector. Then Mr. Anil Razdan came, and now Mr. R.V. Sai, former Secretary Power, is the president of India Energy Forum. Under his leadership, after he took over, unfortunately, there was a COVID period putting restrictions. So he decided that we will hold the webinars and address issues in each vertical of the power sector. I'm pleased to share with you that from September 2020 to date, this is our 36th webinar. We have organized 36 webinars on practically on all issues, vertical issues of the power sector. The recommendations have been given to concerned agencies as our contribution and our thought process on issues to be tackled on priority. India Energy Forum celebrated its 20th anniversary in June 2021. We continue to be stronger while directly concentrating on all verticals of the power sector. We have healthy membership. We are now working out the details to start physical summits. A calendar of events has been prepared. We are following this calendar for webinars from 1st of April this year, and every month we will be still continuing with the webinars and also preparing for physical events. We have been issuing Total Energy as our flagship publication for the last 15 years. After the COVID, we started releasing it in digital form. Every alternate month, we are releasing the Total Energy publication in digital form. With these few words, and welcoming again Mr. Pathak, CMD NPCIL, and Mr. Matharu, my colleague, Director of Power and Director HR with additional charge from BHEL, for accepting our invitation to join and share their views on this subject. With these few words, I again welcome all the participants. Please excuse me for not taking individual name. With huge regards, I welcome you all for joining this our flagship webinar. May I now request Dr. Grover, Chairman of the Nuclear Group in India Energy Forum and member AEC, to please give address on the theme and introduce the speakers. Dr. Grover, please.
Thank you, Mr. Bambani. Good morning to all. Mr. R.V. Shahi, Dr. Kakotkar, Bajaj, and I see several from present here. India has committed to achieving net zero carbon emissions in 2070 the sector, and simultaneously ensure that final per capita energy consumption increases to make it a developed country with a high HDI, like many countries that comprise G20. And amongst G20, Australia, Canada, France, Germany, Japan, South Korea, United Kingdom, and the USA have AHDI above 0.9. The energy is used by end users in various forms to achieve the target of net zero emissions. One has to minimize the use of fuels that emit carbon, carbon-free sources of energy that are making a significant contribution to the global energy mix. And also in India today are hydro, nuclear, solar, and wind. And all of them are being used to generate electricity. Therefore, to achieve net zero emissions, one has to engineer massive electrification of the energy sector. If you look at the statistics for the decade 2010-11 to 2019-20, that the decade before the onset of pandemic, CAGR for electricity generation in India was 5.17%. And this kind of growth rate has to continue for the next 50 years if we want to achieve the target of net zero and also become a developed country. In our forum, that is India Energy Forum, we have been discussing all energy-related issues. And today, we will concentrate on nuclear energy. Nuclear energy has to play a significant role in India's energy mix, and policies have to be formulated by the government to enable it to play that role. In the last week of June, just a week ago, the International Energy Agency released a report titled Nuclear Energy and Energy Transitions. This report looks at how nuclear energy could help address two major crises, energy and climate, in the world today. It also says that establishing zero globally will be harder and more expensive without nuclear. For the expansion of nuclear power, some of the important issues which have to be looked at are safety, technology, supply chain within India, fuel availability, and cost competitiveness. For regulation of nuclear safety, India has established the Atomic Energy Regulatory Board, that is AERB. Over the years, AERB has established its own codes and guides, and these are based on international safety standards. The International Atomic Energy Agency, that is IAEA, has come up with safety standards, and IAEA is continuously updating its codes and safety standards based on operating experience and ongoing research. IAEA also provides what is known as Integrated Regulatory Review Services. On invitation from AERB, IAEA conducted IRRS, that is Regulatory Review Service mission, and this mission was concluded on 20th June, just a few days ago. This was second such mission. The first was in 2015. The IRRS team highlighted the positive work the AERB has done to integrate regulatory processes into an online platform, saying it significantly improved the efficiency of the processes to regulate radiation sources. The review team also welcomed actions taken which directly address the recommendations of the earlier IRRS mission. And these include the improved inspection program, including enhanced training and strengthening the powers of inspectors, updated staff qualification and training programs, the establishing the process for regularly reviewing regulations and guides. In this report, the team said it was important for the government to ensure that AERB has sufficient resources to continue its international engagement in the development of safety standards and exchange of information on nuclear and radiation safety. And this report is available on the website of IAEA. Anyone interested can see it. This is only a small report. Full report will come after 3 months. Now, from safety regulation, let me move to fuel availability. We have discussed this once earlier in India Energy Forum. In 2008, the Nuclear Suppliers Group relaxed its guidelines to facilitate the purchase of uranium by India from the international market. The agreements that India has entered into with various countries for cooperation in nuclear energy provide for India building a strategic uranium reserve. Unlike petroleum, it's very easy to build a strategic reserve of uranium for a long duration. Fuel storage at the plant site to meet requirements for several months is also possible. NPCIL is building nuclear power plants based on indigenous technology. The plant size, which is presently being built, is 700 megawatts, and we'll hear more about it in a keynote from CMD NPCIL in a short while. It is being done at a competitive price, about rupees 15 crores per megawatt. The supply chain for its reactor technology has been fully indigenized, and we have a representative of BHEL with us. He will tell us more about the preparedness of the manufacturing industry to meet the requirements of reactors to be constructed by NPCIL. NPCIL is also constructing light water reactors in technical cooperation with the Russian Federation. And we have a representative of Rosatom with us, and he will tell us about how his company looks at business prospects in India. Let me briefly talk about reactor systems other than what is being managed by NPCIL. A 500 megawatt PFBR is under commissioning at Kalpakkam. All difficulties being encountered are being handled, and the commissioning is moving ahead. This being first of a kind unit, the pace is slow, but I must add, this plant is also fully indigenous. Baba Atomic Research Center is working on the next generation reactor systems. One such system is molten salt breeder reactor. Brainstorming is also ongoing within the department about a medium-sized PWR. We had once discussed this topic on this platform. With this, now let me introduce today's speakers. After the presidential remarks by Shri R.V. Shahi, we'll have 3 speakers. The keynote will be delivered by Shri Pathak. Shri Bhuvan Chandra Pathak is working as CMD, Nuclear Power Corporation of India Limited. He graduated in mechanical engineering from G.B. Pant University of Agriculture and Technology and joined BRC Training School in 1986 to study nuclear engineering, and has rich experience of over 3 decades in implementing nuclear power projects. He has worked at various sites on both PSWRs and PWRs technologies. For PSWRs, he has been associated with all unit sizes, namely 220, 540, and 700 megawatts. Safety is of utmost importance in a nuclear establishment, and it has to be embedded in the culture of the organization, and Shri Pathak takes a keen interest in nurturing safety culture. He was appointed Director Project in July 2019 and was elevated to his present position of CMD and PCIL in February 2022. The second speaker is Mr. Andrei Shevlaikov, and he has been dealing with the development of international business in power engineering in leading Russian companies for the last 20 years. He took over as CEO of Rosatom South Asia in 2017 with the aim of developing and supporting the business activities of the Russian State Atomic Energy Corporation in this region. He is responsible for the implementation of nuclear power projects in South Asia, including India, and projects at Kudankulam and also in Bangladesh are coming up under his leadership. The third speaker is Shri Upendra Singh Matheru. He was inducted as Director Projects BHEL in March 2022. He is also holding the additional charge of HR. He graduated in mechanical engineering in 1984 from Thapar Institute of Engineering and Technology, Patiala. He has also a postgraduate degree in business administration with a specialization in marketing. He is a certified energy manager and teacher. Shri Mathuru joined BHEL in 1985 at Industrial Valve Plant, Goindwal, when the plant was being set up. And he has had a diverse experience spanning almost 37 years in BHEL. He was head of the power sector Eastern region and now is overseeing all the regions as director of projects. With this short introduction of speakers, before we go to Mr. Pathak, today's keynote speaker, I request Mr. Shahi to give his presidential remarks. Thank you.
Thank you, Dr. Pat. Thank you, Dr. Grover, for laying the foundation of this webinar very nicely, and the country is proud of you being a nuclear engineer. Your stature as a nuclear engineer of this country. May I now, as you said, request Mr. Sahib to please give the presidential address.
Thank you. Thank you, Dr. Grover, for a very comprehensive overview and introduction to the topic of today. Of course, in India Energy Forum, we are so much concerned about the rapid progress of the nuclear capacity in the country, that in the last 1.5 years or so, we have organized almost 3 or 4 such discussions. And one was even more comprehensive. That was in last November 21, when Dr. Kakodkar made a very detailed presentation, and we had a very useful discussion. Besides organizing these discussions, we have also had the opportunity of working on what we discussed. If you recall, in the conference that we had, webinar that we had in November, I had particularly also requested NTPC chairman to have a brief discussion and brief intervention, which he did. And that was with the sole objective that whether organization like NTPC could also step in and take it as an agenda to pursue project development, to pursue development of nuclear power projects, so that we get larger amount of capacity in the time frame that we have. This was also coming out of the concern that with the massive solar expansion that we are trying to do in the country, of the order of 450, 500, 600, you name a figure, gigawatt, we do have a real challenge on how to manage the grid and how to manage and balance the loads when we have no solar radiation available in the evenings. And we assume that a reasonable battery backup is going to take some time. So what could be the other important solutions to this ambitious program, which is so important? And it is important because not that the government thinks it is important, because it is really important for climate change concerns, and it is important to balance our highly skewed energy profile in power in favor of coal-based power generation or gas-based power generation. And also in terms of other means of consumption of energy in the petroleum sector, where again we are using the fossil fuel. So it is important from that point of view as well to align ourselves to be in the forefront of having the challenge and addressing the challenges to take care of the climate issues, and at the same time also take care of the developmental needs of our country. So from that angle, our position has been very clear that we have to have the developmental needs also addressed, which would mean that India has to increase substantially its per capita consumption of energy, per capita consumption of electricity, which is one third of the global average, and therefore provide access and provide modern way of industrial activities, modern way of living, modern way of education, modern way of healthcare. So both these dimensions have to be addressed. That we enhance energy production, we enhance energy consumption, and at the same time also address the issue of not being so fossil fuel centric power generation profile. And it is in that context that nuclear power assumes even greater relevance. Not that India did not give importance to nuclear power. India has been one of the few countries where even now we are one of the top 12 large nuclear power producer countries in the world. So if not top 10, perhaps top 12. We have a larger number of countries which produce nuclear power, but we are among the top dozen. And our country decided about nuclear power right in the mid 50s. I think in 1960, 62 or so, we had the Atomic Energy Act. And in the Atomic Energy Act, a rightful place was given to the nuclear power generation. Only thing is that whether we have been able to make use of this enabling provision in the Atomic Energy Act of 1962 fully, or we have a long way to go. So that those were the issues also we discussed in the past. There have been various situations. There was a time when country felt that we have enough uranium. There was a time when we ran short of fuel. At least when I was in the power ministries in the beginning of the century. And Dr. Kakotkar, I'm happy Dr. Kakotkar responded to my request. Only a few days back, we met together in Ahmedabad on a discussion. And I particularly requested him that if he could adjust his appointments to be available today also, and he has been kind. Anil Razdan also, I am told he has joined. So therefore, importance was given. A lot of importance has been given. The only thing is situations, the problems, the challenges, perhaps in the way of fuel. Then when we were together in 2003, 4, 5, 6 or so, we had the issue of nuclear supplier group agreement at the global level, the different type of doubts, different type of concerns globally. And therefore the process has been really slow. And of late in the last 2 years, we have been discussing that why have we continued insofar as nuclear power, which is so important, which is carbon-free power. It is a good answer to climate change issue. It is a good answer now, particularly in the context of solar power expansion in such a big way in India. And why is it that this important ingredient of energy, insofar as power is concerned, has remained in the margin? Of course, wonderful work has been done on medical and other areas through our nuclear system. But then on the power side, I think we always were 2.5%, 2%, and now with massive expansion on the renewable as well as coal, based power generation, we are not even 2%, it is 1.8 or 1.9%. I think this issue has bothered us. So when we did this conference in November 21, and we didn't end with this conference, and nor we will end with this conference, today's discussion as well. Behind the scene, we have been working. That conference also, we had requested the Secretary, Department of Atomic Energy, Mr. Vyas, Dr. Vyas, he joined, and Mr. Sharma, who was the chairman then. He was not to join, but I insisted he to join, and he was nice to have joined. And we had NTPC chairman. And the idea was that why is it that this important provision of the Atomic Energy Act, which enables government organizations to take up, and why is it that we have remained only with one nuclear power corporation? Institutionally, unless we strengthen our network of organizations, build up internal capability, allow, if not total opening of the sector, but partial opening of the sector, how do we get to the figure? When we are talking of 500 gigawatt, we are talking of 600 gigawatt. I mean, right now we should have been 10 lakh megawatt, not 4 lakh megawatt. 1200 kilowatt hour per head per year consumption in India. And I mean, as compared to, let's say, almost 4,000 kilowatt hour of China, and I'm not talking of the so-called Western world and very highly advanced countries. Why is it that we are remaining stuck up here? And then we come to this, that in that, this important ingredient of energy has remained somehow in the sideline. And has this sideline be really on account of something God-given, or could we have done something better, or could we now at least do something better? So therefore, behind the scene, we have talked, and I am very happy that there are some positive developments of discussions between NTPC, the Nuclear Power Group, with the Department of Atomic Energy, Ministry of Power, and this, it is taking some shape. Of course, it might take shape in a formal way in weeks and months, but then it is taking some shape. I would feel that if we have to really make up for the shortfalls that have got created, and it has declined from 2.53% to now 1.7, 1.8%, and it will decline further if we do not arrest it by proper proactive actions. Unless we do that, and in that capital market financing, more organizations, and maybe not now. If we gain confidence, even PPP, private sector, and may not be immediately, but immediately organizations like NTPC, who have financial resources, who have project management capability, who can hire people of the knowledge and expertise and go over this and add to the basket of nuclear power generation capacities. And subsequently, maybe in next 4 or 5 years, we prepare the country's mindset that this is not something which is a black box, that it can remain stuck up in one institutional framework. Whole world, there are different types of organizations who are working for this. Of course, it is very important to have the right regulatory mechanism to see that necessary safeguards of security, safeguards of radiation, safeguards of environmental factors are taken into account. But one more important thing that we perhaps need to do at the national level, and all of us, and we in India Energy Forum and such other think tanks can contribute toward that, to create a mindset in the country in favor of nuclear power. While we should have done much larger capacity, and whatever we do, there again some protests, some resistance, some reservations, all sorts of demonstrations, and all sorts of negative publicity about nuclear power comes in. So therefore, a narrative has to be there, a narrative has to be propagated, to be disseminated, so that people do not have fear about this. I mean, of course, Fukushima did some problem, but then now we have to get back and do this. So my suggestion is, A, financial thing, we should definitely access capital market. In one such discussions, that time the chairman was not there, none of the director of the Nuclear Power Corporation was there. And he said, we have been struggling for budgetary support. I said, after 30, 35 years of your existence, still if you are struggling for government budgetary support, and this organized Nuclear Power Corporation is making money, making profit, why don't you access capital market? Others have done, and that's not a problem. This is a viable, this is a commercially very acceptable, and profit-making organization. So that is one. Project management capability has to see. Manufacturing capability within India, we have to work out. More organizations we should add to expand. And in not more than 5 years, I will humbly suggest that government should consider and should revisit that it should be opened up with sufficient, again, I'll come back again on this, when we have a lot.
Okay, now we proceed further. May I request Mr. Mahajan to call speakers one by one?
Dr. Grover, we have the keynote address today on the overall scenario of the nuclear power generation and the perspective and the requirements and the plans of NPCIL to add to the nuclear capacity through PHWRs and LWRs. We are really honored to have Pathak Saab with us, who has recently taken over as the Chairman and Managing Director of NPCIL. He has already been introduced by Dr. Grover. May I request him to kindly initiate his keynote address. I would like to inform the participants that Mr. Pathak is speaking not from his Mumbai office, but from Rajasthan Atomic Power Plant, where the connectivity is somewhat a problem. So there may be disturbances in between. Kindly bear with him. Mr. Pathak, please.
Good morning, everyone. It's my privilege to talk on Indian nuclear power program in the current scenario with such a galaxy of learned people. I thank the management of Indian Energy Forum to give me this opportunity on this very relevant topic, at least for the Nuclear Power Corporation today. So let us start with some facts. To begin with, let us have a look at energy scenario of the world and our country. So in the year 2020, the total approximately 67% of energy consumption was from fossil fuel, and the share of electricity in the energy mix was just 19.1 approximately percent. Whereas in our country in the same year, energy consumption from fossil fuel was around 81%, and the share of electricity was 24%, slightly higher than the world average. So achieving net zero carbon emission by 2070, we will require twin task of switching to non-fossil fuel in electricity generation and increase of non-fossil fuel in overall energy basket in a substantial manner. As of February 2022, India has a total installed capacity of electricity of around 395 gigawatt. Of this, 106 gigawatt, that is 26.88%, is accounted for by the renewables. Primary energy consumption of India has increased from 12.2 quadrillion BTU in 2000 to 31.7 quadrillion BTU in 2019, growing at an average annual rate of about 5.2%. With this, as India develops and modernizes, its rate of energy demand growth is projected to be around 3 times the global average. So India has already reduced emissions from 28% from 2005 level compared to the objective of 35% by 2030 set out in nationally determined contributions, that is NDC. And now target has been revised as 45% by 2030 as per the PM's Glasgow commitment. To achieve the national commitment by 2050, India expects renewable energy to provide around 80 to 85% of the country's total electricity consumption. While moving towards decarbonization, other sectors like cement, steel, fertilizers, agriculture, other industrial applications, and transport will also have to be decarbonized by primarily involving use of electricity. Next, yeah. So now let us have a look at countries' growth projections. So we can see India's per capita electricity consumption and electricity generation correspondingly is set to increase about 15 to 16 times by 2070. Right now, the electricity consumption is 13 and yeah, come to the previous one. So we can see this is quantum jump. Coming to the certain other aspects of country's energy scenario, presently India's per capita electricity consumption is around 1/3 of global average. It's clear that country's growth and better standard of living depends on higher access of electricity. This needs to be done taking into account the climate change requirements concern raised in COP26 and COP21 and India's commitment thereof. One of them being a national net zero target of 2070. Next. As we all know, in energy growth solely based on fossil fuel will lead to challenges of climate changes. And to address this issue, we need to phase out thermal power stations. Also, intermittency of renewables and associated cost is an issue. Cost of balancing power is high and would be much higher as renewable penetration increases. All this leaves us with nuclear as the best alternate base load option. Green hydrogen production could be a byproduct, meeting India's goal as brought out by Prime Minister recently. That is to make India the largest green hydrogen production hub. Next. Now let us dwell on the variable renewable energy features and its constraint. Renewable energy sources have definitely low capital cost and short construction time, but it is having the issue of intermittency and seasonal variation. Sunshine and strong wind always not be available in given day. Grid integration and balancing power costs are much higher. Therefore, there would be a large import requirement in future to meet expansion needs in the sector. Waste generation is high due to short life cycle. Generally, the photovoltaic panels have a lifespan of around 25 to 30 years. There will be 35,000 tons of solar panel waste in India by 2030. It could reach 7.5 million tons by 2050, placing India among the top 5 photovoltaic scrap creators. We can see there is a large requirement of land for such an expansion just to meet the requirement up to 2030 as per CEA's projections. Meeting the national target of 450 gigawatt clean energy capacity would require around 280 gigawatt of solar and 140 gigawatt wind capacity along with nuclear power capacity of 19 gigawatt. This would require land areas of about 5,700 square meter for solar, 20,000 square meter for wind, and 47.5 square kilometer for nuclear, which is definitely a small value. So you can imagine the land requirement would be enormous to achieve net zero by 2070 if we go entirely for renewables. Now let us come to the tariff. Let us compare the tariff. Nuclear power tariff is of delivered cost, that is demand side. Wind and solar tariffs are on generation side and do not include the considerable cost attributable to grid transmission, since most of the solar generation will happen on wasteland located far away from load centers. Grid stability, grid integration, energy security, meaning there were form and backup generation support is required during adverse weather events. Hence, the demand side nuclear tariff is more lucrative than renewables, unlike widespread perception. On the other hand, it has, for nuclear power plant, it has definitely high capital cost, long gestation period. Nuclear power is clean, safe, and reliable. It has low carbon emission. It's stable. It's dense baseload power, which is unmatched by any other energy sources. The plant load factor is much higher, that is around 80 to 85. Last year, we clocked around 87.6% of overall capacity factor in nuclear power corporation as compared to solar 20 to 22%, wind 35%. It has long economic life of around 40 to 60 years, as I'll see with the statistics. As explained earlier, land requirement is low. Nuclear power projects can be located close to demand load centers, thereby reducing transmission costs. Next. This is the graph showing the carbon emission by various sources. We can see the carbon emission is very low as compared to other sources. Next. Nuclear power could play a major role in green hydrogen generation and operation of desalination plants. The requirement of backing down during daytime when solar is available. This could be addressed by storing the output of nuclear energy during this time through a combination of dedicated pumped up storage system or through diverting nuclear energy during this period for desalination for coastal plants or for production of green hydrogen. A production of hydrogen then becomes a form of nuclear energy, as hydrogen can then be used for transportation or by industry of various applications. As per this International Energy Agency, electricity will account for around 50% of total energy requirement by the year 2050. By that time, almost 90% electricity generation will be from renewables. There will be increased penetration of renewable, which will lead to higher grid integration cost. According to Forum of Regulators, cost of variable regulatory renewable energy integration and balancing power is presently, as per one study, it is around 2 rupees 12 paisa per unit, not reflected in tariff. As India ramps up renewal from 100 gigawatt to 450 gigawatt by 2030, this burden is going to be enormous. As per the estimate of PGCIL, the cost of establishing new transmission line, that is laying of grid, is about 2,27,500 crores. So to optimize the cost, provide balancing power and keeping emission low, nuclear contribution has to increase substantially. So let us see the renewable model in European countries and its repercussions. United Kingdom and Germany. Wind energy meets close to 24% of energy requirement in these countries. The plan to phase out coal in UK by year 2024 and Germany by year 2037. The balancing power is provided by gas, which is mainly imported. Natural gas prices rose due to various factors in the early part of last year. Additionally, North Sea wind dropped in the same year. So the electricity prices skyrocketed in Europe as high as $395 per 1,000 units. If we convert in terms of Indian rupee, it is around 31 rupees per unit. Intermittency of renewable coupled with reliance on fossil fuels such as gas showed fragility in the model. Next. France is reviewing its earlier plans to cut nuclear from 75% to 50%. Germany's plan to phase out nuclear forced them to pay 50% higher electricity prices than their French counterparts. UK released energy white paper in October 2021, Powering Net Zero Future, which emphasizes a major role of nuclear. Apart from these European nations, US, China, Japan have already declared nuclear power a part of their pathway to low carbon economy. Next. Having discussed about the necessity of going for nuclear power in the pursuit of net zero carbon emission, now let us look at the various technologies of nuclear reactors operating worldwide. You can see these are the various technologies, and out of this, PWR, pressurized water reactor, having the highest contribution, 306 reactors out of 440 reactors, operating reactors. And the next one is boiling water reactor, that is 61 reactors are operating. And a pressurized water reactor is a third place, that is 48 reactors of 24 gigawatt. That is the contribution worldwide. Next. The same thing can be shown graphically. So 69% is the total PWRs. Now coming to our Indian nuclear power program. So most of you know the 3-stage program of India. It is sequential with the fuel cycle linkages using indigenous technologies. The first stage is pressurized heavy water reactors, which has reached commercial maturity. The responsibility of executing this stage is being shouldered as of now by NPCI. The second stage is fast breeder reactor, which is being established by Bhavini. The first commercial reactor of 500 megawatt capacity is under commissioning. The third stage is thorium-based systems, which are under development. To ramp up nuclear power in our energy mix, light water reactors are being set up in India with collaboration of international nuclear suppliers as an additionalities. Next. Let us have a look at the rationale behind the 3-stage program. This program ensures self-reliance and long-term energy security, that is to secure the country's long-term energy independence through optimum use of India's nuclear modest resources of uranium and abundant thorium, which is about 25% of world's known thorium reserves. And then the closed fuel cycle, including minimization of waste. Previous. As Dr. Homi Baba said, any substantial rise in standard of living in this region that can be sustained in the long term will only be possible on the basis of very large import of fuel or on the basis of atomic energy. Obviously, the latter is the better option. The 3-stage nuclear power program of country takes us to Atmanirbhar Bharat. Now let us look at rationale of choice for pressurized heavy water reactors. That is the first stage. So it was one of the technologies being developed in the country in the initial stages, and also in parallel, we had cooperation with foreign sources, that is Canada. It involved optimum utilization of modest uranium resources available with the country. Secondly, use of natural uranium as fuel with heavy water as moderator, which is being produced in the country in abundance. Availability of nuclear industrial manufacturing capability in the country. Additionally, pressurized heavy water reactors has features of high neutron economy, higher efficiency in plutonium production. It is inherently safe reactor. Next. Moving to the rationale for choice for light water reactor as an additionality. The need to ensure fast nuclear power capacity addition led us to adopt large capacity light water reactors. It helped develop foreign cooperation, gave access to one of the most popular and proven technologies in the world, the light water reactor, and obtain the technology with lifetime supply of fuel. As a byproduct, we are able to build capacity in manufacturing of equipment and component by Indian industry, setting up of manufacturing and service facilities in India by foreign partners, and construction, erection, commissioning, and operation and maintenance expertise in India as of now in NPCI. With this, there is a potential for export of goods and services to the global market as well. Next. This is the photograph of one of our first reactor, that is Tarapur Atomic Power Station 1 and 2, based on boiling water reactor technology. It was a demonstration of nuclear power in Indian grid that time. TAPS 1 and 2 was set up on turnkey basis by GE USA. Started commercial operation in 1969. It has completed 52 years of successful operation. Next. And next one shows RAPS 1 and 2. The first CANDU reactor, the first pressurized heavy water reactor set up in India in technical cooperation with AECL Canada. Now this photograph shows the evolution of reactors in the country from RAPS 1 and 2, which was a demonstration of technology. Madras Atomic Power Station 1 and 2, which was indigenized after withdrawal of foreign support. Narora 1 and 2 was the first standard PSWR. KAPS 1 and 2 prove the consolidation stage of PSWR technology in India. The subsequent PSWRs depict the commercialization stage. Then we move to operate and upgrade to the higher power reactors, that is 540 megawatt at Tarapur 3 and 4. Now we are close to operating a 700 megawatt PSWR. Coming to 700 megawatt PSWR, it is having advanced design and it's completely indigenous. The core design of 700 megawatt is same as that of 540 megawatt PSWR, but the energy extracted is operated by 25% by permitting partial boiling to the extent of 2 to 3%. Many of first of kind FOAK systems features are incorporated after rigorous testing and qualification in this reactor. Design incorporates safety enhancement evolved from a review of accident at Fukushima nuclear power station. Safety analysis confirms safety under all postulated conditions and meeting safety goal with adequate margins. Design complies with the latest national and international regulatory requirements. Its core damage frequency for internal events at full power operation is very low. It is comparable with any of the best technology available in the world. There is no requirement of evacuating public staying beyond the mandatory exclusion zone area around 700 megawatt primary pressurized heavy water reactor, as design features and reliable mitigating measures are provided to counter any threat to the containment from postulated events. Examples are inner containment lined with steel and the containment spray system, containment and filtration ventilation system. So this gives the additional edge to the 700 megawatt reactors. As of now, we have taken a lot of procurement actions for 700 megawatt reactors, like one single EPC package for turbine island package has been awarded for 6 reactors at a time, worth around 12,000 crore. And these 3 reactors are at Kaiga 5, 6, Chutka 1 and 2, and Haryana 3 and 4. And the purchase orders are placed in bulk for fleet mode reactors, such as steam generators. We have placed order for 7 units, 28 numbers at a time. Forgings for steam generators, 6 unit, 24 unit numbers. In colloid, 800 tubes. Likewise, I have given some of the major equipment. So that shows how fast we are going towards this large capacity addition. So this is, as of now, the overall scenario in nuclear power corporation. There are these are the various operating units at 5 different sites. Total installed capacity is 6.78. And out of this, 4.46 gigawatt is coming from 18 pressurized heavy water reactors and 2.32 gigawatt coming from light water reactors. Next. So this is our performance. We are operating these reactors for many decades with impeccable safety records. There has been no incident of release of radioactivity beyond stipulated limits in public domain in over 52 years. We have the experience of 570 reactors years in operating all those reactors. We can see the public dose in this graph emanating from nuclear power station is almost negligible. We can compare the ARV limit is say 1000 microsievert and the natural background which is there already 2400. So we can see contribution from nuclear power station is almost negligible. Next. As we know, nuclear power is 24/7 with high capacity factor and availability factors. Some of the NPCI's landmark achievement have been depicted in this slide. As already mentioned, completion of 52 years of safe operation of TAPS 1 and 2, oldest reactor in operation in the world today. World record of a continuous operation of 962 days for Kaiga 1, presently second highest. there has been continuous operation of reactors more than a year on 39 occasions. So that shows this stable energy we are producing. NPP is truly a baseload source of electricity. So this is the expansion program which is right now going in India in NPCL. So we can see three projects of 700 megawatt reactors are in advanced stage. Kakrapara 3 and 4, 2 into 700 megawatt. Rajasthan 700, 2 into 700 megawatt. Haryana 1 into 2 into 700 megawatt. And light water reactor, the Kudamkulam 3 and 4, 2 into 1000 megawatt, where construction work is in progress. Kudamkulam 5 and 6, 2 into 1000 megawatt. So these are the 10 reactors which are under construction, totaling around 8,200 megawatt. And next. So these are some of the photographs of Kakrapara 3 and 4, Haryana 1 and 2, Rajasthan 7 and 8. Next. So these are the reactors under construction. Kudamkulam 3 and 4, you can see around 60% physical progress has already been achieved, and Kudamkulam 5 and 6 construction has started in big way now. Next. In addition to this, Government of India has approved 10 reactors of 700 megawatt each, totaling around 7,000 megawatt. And the pre-project activities are in progress at various sites. These units are being established at 4 different sites of the country. These projects have been accorded administrative approval and financial sanction to be taken up with fleet mode to take advantage of volume discount, as I have already explained, through bulk orders, and to ensure continuity of orders to the Indian manufacturer. This is based on the experience which we had in last 10 years, that capacity addition has been slow. So we learned the lesson, and orders have been placed, and pre-project activities at all 4 sites are in progress. Next. So this is the plan of Nuclear Power Corporation. Presently, total installed capacity is 6,780 megawatt, and we will take it up to around 22 gigawatt, and this includes 500 megawatt to be added by a fast breeder reactor being set up at Kalpakkam. So by 2030, our total nuclear installed capacity would be around 22 gigawatt. Next. So this is the first reactor of Kaiga 5-6 of fleet mode, which we have recently started. The excavation work has commenced here, and for which, as I have already told, one big mega package contract is awarded to Messrs. BHEL that takes care of entire turbine island package. And next. And we already have ordered various equipments, and we are in the process of awarding one major contract which will take care of all other activities of nuclear construction, erection, and commissioning. So this way, we should complete this project in less than 5 years, and we are putting all our efforts, and we are seeking the support of industry also. And the future expansion, if we just see, these are the sites which have been accorded in principle approval by Government of India, and wherein the discussions are going on with various vendors like EDF France or Westinghouse USA for various different technologies, and EDF has already submitted the techno-commercial operation offer, with various technical, regulatory, commercial discussions are going on at various levels. Next. A little bit of discussion on small modular reactors, which is an upcoming technology. So small modular reactor, or we call it SMR also. SMR technology holds the promise of bringing down upfront total capital cost leveraging economy of mass production if we go for large number of SMRs, as well as providing flexible generation needed to provide balancing power to renewables, which will have an increasing share of in the future grid, since SMRs have low power levels and smaller levels of decay heat, making safety management simpler and cheaper. SMRs might be suitable for off-site prefabrication. SMRs being small in size, reduce land requirements and offer siting flexibility. These can be deployed in brownfield sites vacated by coal-based power plants. It could bring electricity to remote rural communities, small islands, or military bases where fossil-based generators are prevalent today. Low capital cost and prediction of shorter delivery times reduces the financial risk for potential customers and investors. Also, given their relatively simpler design structure and passive safety system, they are expected to have lower operational and maintenance costs. Russia's academic Lomonosov, the world's first floating nuclear power plant that began commercial operation in May 2020, is producing energy from 235 megawatt. Other SMRs are under construction or in licensing stage in Argentina, Canada, China, Russia, South Korea, and United States of America. More than 70 commercial SMRs design being developed around the world target varied outputs and different applications such as electricity, hybrid energy system, heating, water desalination, and steam for industrial applications. So the possible expansion in nuclear power program in future, if I summarize, PSWR, we may have 3 more sets of 10 reactor fleets. Like right now we are having one of 10 fleet of 7,000 megawatt. So that may add 21,000 megawatt. Large capacity light water reactors at 3 coastal locations may add around 20,000 megawatt. We can work on new technologies, that is fast breeder reactors. We can work on Indian precise water reactors. We can work on Indian small modular reactors of different capacities. Next. So India has mastery in PSWRs now and experience in light water reactors as well, including BWRs. So India, PSWR will continue to be the mainstay in our Indian nuclear power program in near future also. Large capacity PSWR will continue to be added in our fleets. More large capacities in terms of light water are expected to be added in future, maybe including Indian PWRs. Second stage set to take off with the first commercial fast breeder reactors to be commissioned in near future. So there are a number of advanced reactors like metallic fuel-based, thorium-based, thorium fuel reactors, high temperature reactors under development in the country. India is also exploring possibilities of developing and deploying small modular reactor of different technologies, mainly light water reactors. In future, nuclear capacity addition beyond 2030 could come from a mix of reactors, mainly PSWR, NWR, and fast breeder reactors and other advanced reactors. I hope within the allotted time, I could give my perspective, and I hope it should be useful, meaningful, and we can discuss if there are any questions on the present talk. Thank you very much for patient hearing.
Mr. Pathak, are you going to be there throughout? Then question can be raised later, and if you are not going to be throughout, then it can be done now.
My request would be, because already there are some other programs. So if I am permitted, maybe I may stay for another half an hour. If that suits, I think I will continue. But beyond that, I have to go to some other program.
Then what do you say, Dr. Grover? It will be good to have a few questions
to
him.
Yeah, we can have questions on this section right now.
Yeah,
so that he can then move to other engagement.
Yeah, it's a very, very substantial and very comprehensive presentation, Mr. Pathak, and you have given a good ray of hope. But with all this, if we take next 20 years, in 20 years, India's capacity will grow up to, let's say, 15 lakh megawatt.
Yes.
What is now 4 will become 8 plus in the 10 years, and in 20 years, it will become, let's say, 15 gigawatt. Can we hope that by that time, if not 5%, at least 4% of the total, which will be almost 50 to 60,000 megawatt, can be done internally? Number one. Number two, whatever programs that you have now projected, are you not dependent on budgetary support, or you are dependent on budgetary support?
Yes, sir. So I will answer the first question first. Yes, right now our target is to bring this level to around 20 gigawatt by 2030, and because we are already working on this, so I do not have any uncertainty in this. This is first question, and maybe yes, another 20-25 years we can take it to around 45 to 50 gigawatt. Of course, we'll have to have, as I've already discussed, a combination of light water reactors and pressurized heavy water reactor, on which discussions are going on, and with the introduction of fast breeder reactors, so that will add to our capacity. As far as the budgetary support is there, right now we have got 3 big projects, that is Kakrapara 3-4, Rajasthan 7-8, and Kudamkulam 3 and 4. The overall investment is huge. So there we are not seeking any budgetary support from Government of India. These 3 projects worth around 1 lakh crore is purely funded by Nuclear Power Corporation, and we are getting financial resources from the market. There are companies, even government companies, offering us long-term loans, and we are in discussion with various companies like who are controlled by Government of India. So with the present program, probably I personally feel we will not have any difficulty for funding these projects for this 19 gigawatt. But for light water reactors which are to be imported, where the capacity addition will be enormous, so there probably we'll have to think something different. Maybe we can go for some sort of joint venture, or maybe we will have some financial special purpose vehicles. So as of now, yes, I do not think there is much problem. Yes, there are projects which are under construction, which are supported from equity by Government of India. We are getting, we are able to manage with the available resources as of now.
Okay.
Sir, I have one observation, if Shai Sir permits me.
Yeah.
Okay.
Pathak Sahab, your information on possibility of additional 3 more modes of fleet mode, that means 30 sets. I think that's a very sweet note for the ears of the manufacturing industry. It will be better, in my opinion, that in case the manufacturing industry is prepared for manufacture of these in advance, so that the planning for capacity addition at their end also, though I believe that Mr. Matharu is there with his team from BHEL, and there are some people from L&T also. They will vouch that enough capacity is available now with the dip in the coal-based power plants, the capacity generated by the manufacturing units that is available for the nuclear power equipment. So if some sort of association with the manufacturing industry at this stage itself for the possible expansion of the program through these additional modes that is made with the industry, it will help them to plan the manufacturing in advance and reserve the resources for the manufacturing. One major complaint which has been by the manufacturing industry is off and on, switch on, switch off loading. So if they are assured of a future load on a continuous basis, I think they will also prepare well, and that may go good for the nuclear power generation program.
Yes, sir. Yes, sir. Yes, sir. I'll just respond to this. And you must have seen we are going in bulk procurement mode now. So as many as reactors, the steam generators for 3 or 4 or 5 reactors. So what we are doing is we are awarding contract to major who are basically qualifying the bidding requirement, and we are developing 1 or 2 more agencies also. So that we have got the adequate infrastructure available in India, and with this, the steam generator, which earlier used to take around say 5 to 6 years or even 7-8 years, now we are able to manufacture these steam generator in 36 months. This is the record we have recently. And same way, since we are in the bulk mode, so in case there is delay in one of the project, so this particular equipment can be diverted to some other. And likewise, earlier we used to import a lot of equipment like primary coolant pump. So we have placed development order within India so that these pumps are available in India. Critical pumps are available in India. The spares are available in India. So we don't have to import of any such equipment from outside. Now from in fleet mode from Haryana 1 and 2 onwards, we have placed a big order on BHEL. So the turbine which were being imported from G Alsam earlier, now these turbines will be manufactured in India. At a time, around 6 units will be supplied, these Indian-made 700 megawatt turbines. So these are the various actions we are taking so that there is a continuity of orders into the market. The talent pool is retained by the industry, and the delays which were earlier taking because of the delayed supply of the equipment, non-availability of the orders from nuclear sector will be addressed. But definitely the industry has to be ready for taking up the construction and erection and commissioning jobs also. So this is the area where industry has to come forward, and industry has to change its lookout as far as the quality assurance is concerned, because nuclear technology is very niche technology wherein the nuclear safety is the utmost criteria. So we do not basically compromise with any aspect of nuclear safety. So that is a quality assurance is required. So all the industry partners, especially those involved in the construction and erection, should not compare this activity with any other conventional activity. So this is where probably we are lacking. So this is through this forum, my request to the industry partner is there. Let us work on this as well, so that we have got a strong infrastructure agencies available in India.
Thank you.
I would like to ask, Pathak Saab, the major capacity addition is going to come from the larger units, 1,000 megawatt light water. You have listed the projects. So what is the stage of these projects now?
Yeah, so that's what I told. Around 8,200 megawatt is already under construction. This is one, and the 8,200 includes 4,000 from large reactors, that is 1,000 megawatt, and another 4,200 from pressurized heavy water reactor. So out of these 10 reactors, first 2 reactors of 700 megawatt, that is at Kakrapara 3 and 4. Kakrapara 3 has already been commissioned, connected to grid, and we have operated up to 50%. And with some commissioning checks and modification is going on, we will restart the reactor. And second unit is about to be commissioned, because the major activities have been performed, including one of the very major milestone of PST hydro test is already completed. So we are expecting early next year, the second unit also will go critical. And the other 2 sets of 700 PSW are at Rajasthan, where I am presently today available. So the physical progress is around 80 to 90%. So work is going on well there. And Kudamkulam 3 and 4, 2 into 1,000 megawatt. Physical progress is around 60% and it's going on well. And other 2 reactors, yes, that's just the construction work has started. It will take some time. And as far as the next 7,000 megawatt is concerned, So for which we have 4 sites, and this pre-project activities are in progress, and one of the reactor construction work we have started in the first stage of construction, that is excavation, we have already started. And for other part, techno-commercial discussions are in progress before going for some final agreement with various vendors.
But what about those big projects with 1000 megawatt? The future big projects.
वही तो बताया उन्होंने 8400 में वो भी है ना
1000 megawatt already this construction has already started.
I think now, if you permit, considering the time, we should move on.
Yeah, I think now that's all right. That's because Mr.
We should
Pathak would have
move on,
gone.
and I think maybe Mr. Mahajan, you can start inviting the next speaker. Maybe question and answer we can take up at the end.
I would before that I would like to thank Pathak Sahab, because he may be leaving in between, for a very elaborate and exhaustive presentation on the overall nuclear program. I think he covered the technological status and the capacity addition potential of all the available technologies, whether it is PHWR or light water reactors. Even he touched about the small modular reactors. It was very nice to have him continuously without any break in the communication. Last time, when the beaming was done from Rajasthan by Shri Sharma, that time there were a lot of problems, but this time it has been very smooth. And his presentation is a very welcome indication of the interest of government in increasing the capacity generation from the nuclear power. And I hope the manufacturing industry will respond well to the increasing needs. Thank you, Pathak Sahab, once again. One area which you mentioned in one of your slides was the need of expediting the capacity addition through larger sets which will come from the LWRs. We are fortunate to have with us Mr. Andrei Shevlyakov, who is the CEO of Rosatom South Asian Marketing, and he is overseeing the 6 sets of 1000 megawatt VVER awarded to Rosatom by DAE, and 2 of them they have already been completed, and they are generating power and supplying to grid. Other 2 are in very advanced stage, and balance 2 work has started. So to speak on the potential of the LWR technology in meeting the enhanced capacity requirement from nuclear power generation, and what Rosatom is able to contribute in the overall power generation scenario of nuclear in India, we would request Mr. Andrei to kindly make his presentation.
Okay, good afternoon, dear ladies and gentlemen. So first of all, let me thank you, organizers of this event, for inviting me. I am really very pleased to be invited to speak today in India Energy Forum webinar and to present our company. So, and I would like to thank very much Mr. Pathak for his very brilliant presentation. And actually, I would say, so after so comprehensive presentation, there is actually nothing for me to add, because some of his slides really dedicated to the contribution of Rosatom to the development of Indian nuclear program development. So nevertheless, I will try to add something in my presentation. And for those who don't know me, or at least just know my face and who don't know me, so my name is once again Andrei Shevlyakov, and I am CEO of Rosatom South Asia company. So, and just before I start my presentation, just a very small remark to Dr. Grover's introduction of mine. So I'm not responsible for the implementation of Kudankulam and Raipur project, but I'm responsible for the supporting the business, current business here in this region in South Asia, and definitely in India. And one of the core role of our company here is to help to develop the new opportunities for group of the Rosatom group of companies here in these regions. Well, to help develop and support our group of companies, not only in the nuclear sphere and technologies of business, but also for the non-nuclear technologies also. So let me start my presentation. And before I start, I would say that my today's presentation, the core idea is to think about our future, let's say. And I would say that, in my opinion, there is no future without our history and without the contribution today. So let's just think a little bit about yesterday, today, and tomorrow of our time-tested partnership with India. So I don't want to go to the very details of some milestones. You are very well aware of them, but I cannot help mentioning several of them. So far back in 1988, the Prime Minister of India, Rajiv Gandhi, and the head of Soviet Union at that time, Mikhail Gorbachev, put the first brick of future nuclear cooperation between our two countries by signing the bilateral agreement between India and Russia on cooperation on construction of nuclear power plant in India. So after the declaration of the state sovereignty in 1992 in Russia, the bond between our countries has only continued to expand. And I would say that as a result, Indo-Russian cooperation has achieved, in my opinion, unparalleled milestones in partnership in the field of nuclear research. So later on, recently, Prime Minister Narendra Modi and Russian President Vladimir Putin and Tamil Nadu Chief Minister late Jayalalitha dedicated the first 1,000 megawatt of Kudankulam nuclear power plant to the service of the Indian nation to mark another historic tie-up between India and Russia. So, and it would be not fair enough just not to mention that the partnership between our countries is limited only within this region, I mean, that India and Russia. But in 2018, India, Bangladesh, and Russia signed agreement for cooperation in the construction of Bangladesh's first nuclear power plant, Rupur. Well, coming back to our flagship project here in India, so I would say that Kudankulam is located on the shore of Indian Ocean in the state Tamil Nadu and is the southernmost VVR power plant in the world. So you know that the first stage consisting of power unit number 1 and 2 was commissioned in 2014 and 2017 respectively. And having two working units, 1,000 megawatt each, and 4 units under the construction stage, Kudankulam and PP, is the biggest nuclear power plant in India with total installed capacity 6,000 megawatt here in India. And I would also to mention that it is also currently the biggest foreign project of Rosatom in its portfolio. So speaking about our presence, Rosatom group of companies presence in this region. So there are a few areas, addition to the nuclear power construction, which I have to highlight. So once again, together with you, we have constructed power units 1 and 2, Kudankulam and PP, and construction of units 3 and 6 in process. I think that somebody's mic is unmuted. You also are aware of that recently 12 fuel company of Rosatom has supplied the first batches of TVS-2M nuclear fuel to India for the 2 functioning units 1 and 2 of Kudankulam. With my honor, I would like to inform you that recently, opposite to nuclear power construction, we, I mean that Rosatom group of company signed a distribution agreement with Indian partner for nuclear medicine, and currently we are preparing to participate in the tenders to supply Russian cyclotrons produced by Rosatom to Indian AIMS projects, together with supplying of isotope products. Also recently we have signed 2 sets of contracts with Indian partners for supplying of carbon fiber products, which is a global trend, just to use these composite materials in many areas of the production, different types of products, starting from the cars, sport, requisites, and also is applied in nuclear power. So I can also mention that our Russian nuclear power industry exhibit is opened in the Scientific Research and Technology Center located in Chennai in Tamil Nadu. We are also very active in developing some fields of, in the field of cooperation, some, let's say, different areas and expertise, which is in background of Rosatom, such as like comprehensive security facilities, simulators, both also for nuclear, for thermal power, for oil and gas, and other industries. We are also negotiating with one of Indian company to supply machines for the Indian market, and many, many more. So now coming back to, let's say, our business, I would say that cooperation tomorrow calls for extra work for all of us today. So we cannot move forward as fast as we can with nuclear if it should not be considered green in the total energy mix, and given the same amount of respect, efforts, and importance. As per International Energy Report, over the past 50 years globally, nuclear power has avoided about 55 gigatons of CO2 equivalent emissions, which is nearly equal to 2 years of global energy-related CO2 emissions. According to our calculations, in 2021, Russian NPPs made it possible to save more than 10 crore tons of CO2 equivalent in emission. And across the world, operating NPPs of Russian design save more than 21 crore tons of CO2 in a year. So during climate change conference COP26 in November 21, Russian Federation announced the adoption of a green taxonomy that aligns with international standards. As per official document, nuclear energy projects were considered, or I would say have been considered, as green projects. According to my personal rough estimation, in financial year 2021-2022, Indian NPP saved more than 2.3 crore tons of CO2 equivalent in emission. Our experience shows that savings in CO2 equivalent and overall greenhouse gases emissions in India can be even higher if nuclear energy will be given the same attention as other green sources of energy. So We in Rosatom is open to share its experience and collaborate with Indian partners to move forward up the green and sustainable road. So I asked this question to myself: why do we even need to move up this road? According to the Power Ministry, peak power demand in India surged to a record high 200. A bit more than 207 gigawatt on 29th of April this year. According to the official projection done by Central Electricity Authority of India, the peak energy demand of India is expected to increase more than 2 times in the next 15 years under optimistic scenario by the year 2036-37. So, are we able to satisfy the growing demand of energy in India with only hydro, wind, and solar power? I would say probably, but will be very, very difficult. So on this slide, you can see the summary of life cycle greenhouse gas emission intensity from various electricity sources. Well, nuclear power's life cycle emission of greenhouse gases is about the same as wind or hydro or solar, but plant load factor is higher than all of them, including thermal. So till today, nuclear is the only source of electricity that can produce large amount of electricity 24/7 with very low carbon emissions. As an ideal source of energy to satisfy growing demand of electricity in India, nuclear, in my opinion, is green and sustainable way to go. For many years, Kudankulam NPP project has been a symbol of close cooperation between Russia and India. However, we don't want to stop at what has already been achieved. Rosatom has all the most advanced nuclear power technologies. So together with you colleagues, we are ready to launch the serial construction of the state-of-the-art Generation 3 plus Russian design nuclear power units at a new site in India. And just to add that Rosatom's VVR reactors are among the world's widely used reactors, by the way. And VVR plants have proved their high reliability over more than 1,300 years of operation. Since the commissioning of the first VVR power unit in the 1960s, the technology has been providing safe and affordable electricity across the world. Now, of course, the advantages of large-scale nuclear power plants are obvious. They provide access to reliable, uninterrupted, and low-carbon source of electricity for the high energy demand and well-developed infrastructure. Today, Mr. Patak already mentioned about small modular reactors and even the experience of Russia in this field. So, I would say that SMR occupies a different niche. They supply power to remote regions, island states, areas with lower power needs to specific industrial projects, for example. So, and of course, there are other clear advantages of small modular reactor technologies, including their modularity. So, among them, the ability to quickly scale power up and down to meet demand, quicker construction periods, and the lower startup costs. SMR can provide energy to areas where large capacity nuclear power plants are either economically inaccessible or inappropriate due to some geographic or territorial restrictions. And meanwhile, SMR provide equal energy opportunities for people across the world. Well, summarizing all the above mentioned and saying that I'm absolutely sure that you have heard about the latest tech advancements many times and know it very well. And the presentation of Mr. Patak said that you know it even better than me. So in the very end of my presentation, I would like to call our partners in India to consider collaboration on the following areas of industry, like, first of all, we should continuously together work on successful completion of ongoing projects in India and think, and we have already started thinking and negotiating to launch of new site. Increasing knowledge exchange in science, culture, research, and sustainable development goals, strategic and projects. So successful partnership in Bangladesh shows that India and Russia can join hands in development of civil nuclear energy projects in third countries. Localization of the NPP equipment and fuel manufacturing. So recent and emerging trends of SMR is a great area of our possible future cooperation, which can help to solve energy problems in remote areas. So you know that we are working on our pilot project for the first land-based small modular reactor in India. One more area of collaboration is joint implementation of research reactors projects for research, development, and education and training. And at the end, according to the, let's say, Indian program, and which is a trend of worldwide, and here in Russia, we are also thinking about it. So trying to convert decommissioning and existing coal plant infrastructure, which can be based for our nuclear power plant. So this is the end of my presentation. Thank you very much. And the only I can say in the end of my presentation that I think that there is no other way but to continue and deeper the time-tested partnership between our countries. So thank you so much.
Thank you, Mr. Andrei Shevlakov, for a very brief but comprehensive presentation of the contribution of light water reactors, which is being made into the Indian nuclear power program through your 1000 megawatt PVR technology. Well, I'm aware of the great localization work which has been done by Rosatom, and your presentation indicated the various area of cooperation with the Indian industry also, where the localization can help. Even in the project which Rosatom is executing in Bangladesh, I believe a lot of cooperation has been taken from NPCIL or DAE and the Indian industry. I wish that the next 6 sets of 1000 megawatt or 1200 megawatt reactors, which are likely to be established in West Bengal, as per the presentation made by Mr. Patak, he indicated 1000 megawatt. The role of Indian industry and the Indian partners in establishing these LWR technologies that will enhance substantially, and that will give a good opportunity to the Indian industry also to grow or manufacture of LWRs. So your question answer session will be taken up when Mr. Shahi takes up the concluding session. Till then, I thank you very much for very exhaustive and lecture and maintaining the time. May we now move on to the next presentation by Director Power, Mr. Matharu, BHEL, who holds the additional charge of HR also. The power programs which have been indicated by DAE from time to time, and today Mr. Patak elaborated the need for enhanced capacity generation and the programs which NPCIL is envisaging. The preparedness of the Indian industry for meeting those requirements through the Atmanirbhar Bharat or Made in India programs, that is very, very essential. I'm very happy that one of the leading manufacturing industry has agreed to participate in this program to assure the nation that the Indian industry is well geared up to meet the enhanced requirement of manufacturing power plant equipment from the nuclear resources. May I request Mr. Matharu to kindly start his presentation.
So I'm really happy to be here in this nuclear energy group and amongst such luminaries and distinguished industry colleagues. It is my privilege to be part of this India Energy Forum. And it also brings a feeling of pride when we think about the immense contribution in the nation building that India's nuclear program fraternity has been providing. Despite adverse, we feel proud that the programs associated with nuclear segment in India have grown in strength over past several decades, in spite of international sanctions, and that today we have made significant headway to realize the dream of Dr. Homi Jahangir Baba, the father of India's nuclear program. And definitely, as CMD NPCL mentioned, the journey of this organization in this regard is definitely notable. Currently, nuclear power constitutes hardly about 2% of installed capacity, 6.78 gigawatt. But what I could see from presentation made by CMD NPCL is that 22 gigawatt by 2030. Though CA reports mentions about 5% contribution by the end of that decade, that is 2030, which is approximately 40 gigawatt. With specific focus on the manufacturing capabilities and more particularly what BHL has contributed to that, I would like to mention that BHL charted its own journey and became one of the largest engineering and manufacturing enterprises of its kind in India. Our company was established with a vision to become a global engineering enterprise, providing solutions for a better tomorrow. And we have nation building as a core of our objective. Right from mid-60s onwards, we have been able to create an entire ecosystem of engineering and manufacturing of power plant equipment. And since then, we have been in the leading position in power, industry sector, industry and infrastructure sector. In power sector, we are in the business of thermal, gas, hydro, nuclear, emission control equipment, captive power plants, transmission, renewables, and of course, we are diversifying in other segments also. Though these things are known, very, very well known, but for the sake of repetition, I would like to say that we are offering thermal sets up to 800 megawatt with supercritical technology, gas turbines up to 297 megawatt, hydro sets up to 400 megawatt, and nuclear turbine sets up to 730 megawatt. And with regards to oil and gas industry, transportation, defense, aerospace, e-mobility, we have another sector which is catering industry sector, which is thus we have a comprehensive portfolio comprising of different products, systems, and services, and which is a vast range of engineering and manufacturing capabilities, which is supplemented by capability of execution. So far, BHEL has completed installation of more than 1,000 power plants in the country. I'm talking about the domestic presence only. And more than half of the electricity generated in India comes from BHEL supply sets. If I speak in terms of the installed capacity, BHEL has contributed to installation of 195 gigawatt capacity, out of which 162 gigawatt is in utility segment. And over a period of time, we have enhanced our manufacturing capacity from 2,000 megawatt to 20,000 megawatt through various modernization capacity addition programs. in the indigenous sector, no, whatever capacities were created to cater to the requirements of our sector, the state-of-art machinery installed in different units across India can also cater to manufacturing of equipment required for nuclear power plants. And in that sense, BHL has a proud, we can very proudly say that BHL is one of the very few companies associated with all the 3 stages of India's nuclear power generation program. In the primary side of nuclear plant, BHL has already supplied 43 steam generators along with reactor headers and shields and C&I equipment. I'm sorry, I've not made any formal presentation. I'm just speaking from the notes which I have. And unfortunately, the video at my side is not functioning because of some technical problem. For the first stage of nuclear power program, BHL has been able to support NPCL in its journey from 220 megawatt rating nuclear power plants to 540 and now to the current 700 megawatt nuclear power plants, and which has been done with a combination of in-house development and indigenization of turbine technologies from foreign suppliers, supplementing the efforts of the country in self-reliance. Out of the total 18 PHWR sets, BHL has supplied 12 numbers of turbine generator sets, which is a significant share. For the second stage of nuclear power program also, BHL has been able to provide support to NPCL by installing this turbine of first unit 500 megawatt at Kalpakkam for Bhavani, that is Bharatiya Navika Nigam Limited. And for the third stage, that is HWR, we are still in the design stage, and which we also have an association with BRC on this subject. With regard to LWR also, we have association with Kudankulam project, where these are the foreign cooperation projects where BHL has executed erection of turbine generator for Kudankulam unit 1 and 2, which are already commissioned. And so this foresight of planners of nuclear program fraternity and government of India have also given approval for setting up of 10 nuclear power plants in freeze mode, which CMD NPCL has already apprised. And BHL is also actively involved in execution of these projects in mission mode, and we have started the process of consolidation of our manufacturing facilities and wherever required, some capital equipment, capital budget proposals have also been sanctioned. BHL is also looking for further expanding its portfolio in the nuclear segment by catering to the primary side also. Like recently, we have picked up production of manufacturing of moderator and D20 heat exchangers, which are being made at our Bhopal unit. As further development, BHL is also looking forward for participation in small modular reactors, and our Trichy, Haridwar, and Hyderabad plants shall be able to service all the requirements in this regard. And definitely, we are looking forward to associate with the development of the prototype. In view of various environmental concerns which have been pointed out by earlier 2 speakers, I strongly believe that nuclear power will be emerging as an alternative source of base power, and it is going to emerge as a viable option for the country. With BHL's pan-India presence, 16 state-of-art manufacturing units, and 15 business offices, 8 service centers, and 4 regional offices, along with several ongoing sites, BHL is fully equipped to offer equipment and solutions for nuclear program. And we would look forward for a strategic partnerships for contributing our best to the growth curve of nuclear power.
Good.
As CMD NPCL has mentioned that we also be proud of this KAGA, when KAGA created a world record of continuous operation of 960 crews, which demonstrates the kind of equipment that we can deliver. And recently, we had also worked for advanced ultra supercritical technologies, and working on supercritical sets as well as AEOC has given us experience in dealing with very difficult metallurgies and special materials. And our setup of Central Foundry Force Plant at Haridwar also can cater to different requirements of special materials. On the CNI side also, we have been able to demonstrate this control center instrumentation package at Kakrapar, which have been proven capabilities, and that is why we also were involved in upgradation of NPCL CNI system at our plant also. And recently, in association with the NPCL, we are also working for substitution of equipment like boiler feed pumps under the Atmanirbhar program to support 700 megawatt fleet mode program. So that way, many other manufacturing organizations, including BHL in India, have supported the nuclear power program, and particularly NPCL. And now that BHL is representing a unique, represents a unique engineering, manufacturing, and engineering and erection and commissioning organization for the development of dedicated talent pool for a nuclear segment. And with that, I would like to, since we are running short of time, I would like to thank each one present here and India Energy Forum for giving me this opportunity to be part of the meet. Thank you.
Thank you.
Thank you, Matharu Saab. I think one thing is
Dr.
coming on.
Dr. Grover, now I think you can, I have to leave for another meeting. So Dr. Grover, if you can take care of the question, answer, and conclusion.
Okay.
Thank you.
I'll first notice that questions were posted by Kaustubh Shukla earlier as to, in spite of why so many positive attributes, why nuclear program is going slow. The answer to this is the fact that till 2008, it was not possible for India to import uranium, and uranium availability was a constraint for augmentation of nuclear power program. That constraint has been removed only in 2008, and subsequent to 2008, already Government of India has approved construction of reactors in fleet mode. And we are, as Mr. Pathak said, that how bulk orders have been placed by NPCL, and we are moving ahead in that direction. Now, if there are any more questions, then I can take up. And there were two questions by Mr. Sushil Soni. That also I will take up. But any more questions from anybody else?
If you permit me, I have one question from Andre.
Yes, please go ahead.
Mr. Andre, you say in the second stage of your contribution to the Indian nuclear power program, through another 6 sets of 1000 or 1200 megawatt, how much indigenization you are envisaging? Will it be limited only to the civil works and maybe primary side, or you are looking into the indigenization and involvement of the Indian industry in the reactor part of it?
Yeah. It's first of all, thank you for the question to me personally, and second, this is a very common question on every webinar and every meeting when Rosatom's representatives takes part. And of course, you the answer is already really better than me, because many presentations have been done and dedicated to the localization. And this is a very important question to, first of all, to our Indian partners and for us also. According to the, let's say, my recent slide, which shortly described that, and you know it very well, we have been very closely and in detail working with our Indian colleagues to increase the share of the localization part for the forthcoming units. So I have a slide describing this exact, I wouldn't say that it is, we are not able to talk about the exact figures about this for now. I will share, Mr. Mahajan, with you this slide about our estimation based on our discussions, and you may share with all of our colleagues and participants of this webinar, our view and opinion. I only may say that the share of localization for the next for forthcoming 6 new units will be increased dramatically in comparison to existing share of localization.
Okay, then I take up now the question from Mr. Soni. He has a question regarding the flexing of nuclear power. Now, I think this question was asked once earlier, and Mr. K.N. Vyas, he made a presentation in this very forum sometime back when he explained the design of the fuel and how in PSWRs we have a collapsible clad and flexing is not possible. This was explained in detail at that time. The short answer is that the present design of PSWR, the way we are operating, flexing is not possible. We have to go in for a major design modifications before flexing can be made possible. Your question on two-part tariff, these two are related. Once we are not flexing, there is no possibility of a two-part tariff. I hope, Mr. Soni, I have answered your question. Okay. Now, let us see if...
Sir, flexing or no flexing, two-part tariff would be in the right direction. That's something which we think, sir.
Now, I think this is something which we'll discuss offline. But once we don't have any flexing, what's the use of having two-part tariff? This is something which I'd like to understand more from you. I'll have make a phone call and I'll talk to you on this. Okay. Are there any more questions by anybody? Yeah. Yes, Mr. Sharma.
Dr. Grover, I was just looking at the global investments of different energy sources, and I found for last 1 or 2 years or couple of years, the global investment on nuclear power is among the lowest. So what could be the reason and what could be the big push which could be given to the nuclear sector globally?
I think in between the voice was not audible. Can you repeat?
I'll just repeat it. The global investment on nuclear energy is the lowest in last couple of years. So what could be the reason and what could be the fillip could be given to push up the investment in nuclear energy?
Well, I think global investment in between has been lower, but now if you see after the Glasgow summit, there's a lot of push being given to nuclear in several countries. Even those countries which had earlier decided to not to go in for any expansion of nuclear power have taken up nuclear power. An example of such a country like Netherlands, which were earlier not thinking, they are now thinking in terms of 2 more reactors. France is thinking in terms of 6 reactors, definitely, and it could be 6 + 8. UK has a major program, and this was included in the presentation by Mr. Pathak. So just by going by just last 2 years is not enough. One has to look at on a long-term basis, and I do see a lot of expansion which is envisaged in nuclear now. I referred to when I was right in the beginning, I was introducing, I referred to the book report just released by International Energy Agency, Nuclear Energy and Energy Transitions. That's available on the internet as a free download. It gives the latest scenario in this regard as to how many countries are now envisaging going in for nuclear energy.
And when Japan is going to come back onto its full capacity of 50,000 megawatts, I believe that Kashiwazaki Kariba is still not being put on stream.
I will not be able to give the latest status as to when they will be able to come back, but they are slowly coming back to nuclear, knowing pretty well that there is no other source possible for them.
Thank you. Thank you.
Do we have any other question?
Grover Sahab, I have one submission.
Yes, please.
You know, it's very clear that in the Indian nuclear power generation program, besides the PHWR, which will be the mainstay, LWR and SMRs are going to play increasing role. I think it is the right time if Department of Atomic Energy involves the manufacturing industry, or I will say that manufacturing industry has a lot of design capabilities also, in the program for developing SMRs for application in the Indian segment. I remember when Kakotkar Saab, I don't know whether he's still there, when Kakotkar Saab, when he was the project director of R5, which was later on renamed as Group, the BHEL was fully involved in the manufacturing as it was being designed and approved. So similar strategy, if it is taken for SMRs, and at this stage itself, the industry in India can be involved in development of a prototype or maybe a medium scale production that will help expediting the implementation of this technology.
Well, yes, Mahajan.
Matharu Saab ne
Yes,
just
sir.
briefly mentioned.
Yes, sir. Actually, इसमें ऐसा है कि we already have initiated some work on this, but definitely when this prototype development is happening, we are looking forward to associate in this activity with BARC. So already we have initiated some discussion with them, but let us see how we can proceed.
Good.
First of all, let me say that the nuclear power program based on PSWRs has come to this stage by the manufacturing, which is continuously being done by Indian industry. Indian industry has been always with atomic energy. They have been supplying equipment. Equipment has been developed jointly by NPCIL and Indian industry, and this will continue in the future. This is one area where there cannot be any two opinions about it. It has happened in the past and it will happen in future also. With regard to SMRs, I will go to the extent of saying that Indian industry has so much of experience. They can take the example of Rolls-Royce of UK. They can form a consortium and develop SMR on their own. There is nothing in the Atomic Energy Act which prevents them from doing it. Why they are waiting for atomic energy? I will tell BHEL, L&T, Godrej, all these industries to come together and develop an SMR. After having so much of experience in this area, why don't they take the lead? While atomic energy is working on it and it will definitely come up with some program, the reverse can also happen. So here I request equipment manufacturers to come together and find a way out of developing an SMR.
Good.
Okay. Now I look at, we have exceeded our time limit quite a bit. So it's time to stop here, but I just like to highlight one particular point. Mr. Pathak made a good presentation where he explained the total about 700 megawatt reactor. And if you notice in the 700 megawatt projection which he made, there was one sentence which said that CDF, that core damage frequency of 700 megawatt, is comparable to the best in the world. This essentially denotes the level of safety which NPCIL has been able to achieve over the years. This core damage frequency, this denotes it's a kind of measure of the safety level that even in the various accidents, the core should not damage. So core damage frequency of Indian 700 megawatt PSWR is very low. This point is something which I wanted to highlight to convey that this design of PSWR is comparable to any best reactor in the world. With this, I think it's time to close. I will request Mr. Mahajan to propose a vote of.
On behalf of the India Energy Forum, I would like to thank all the speakers who had made excellent presentations on a topic which is very, very important if India has to achieve the green energy targets by the stated period. And I would also like to thank all the participants for their very active participation. Since we have already overshot substantially, I would like to end up by thanking all for making this webinar a very, very successful webinar. And it seems that the Indian industry is ready for the large scale manufacture of the power plant equipment from the nuclear sources, because enough capacity is available and DA should be successful in going ahead in meeting its projected requirements. Thank you very much to all who have participated and also those who wanted to participate but could not. We have the video recordings. If any portion of the deliberation is needed, please get in touch with the IEF secretary.
We
Thank
will.
you.
Thank you, Mr. Grover. Thank you, Mr. Mahajan, for a very, very, I would say, successful webinar. We had more than 90 participants. It has been a very, very encouraging webinar in the particularly good topic. Thank you very much. Have a nice lunch. Unfortunately, we are not able to offer you a lunch because this is webinar, but definitely we will have sometimes the physical webinar where we can have lunch together. Thank you very much. Thank you very much. And let us hope that India will be able to achieve the increased capacity in the from nuclear in the total power generating capacity. Thank you. Thank you. Thank you very much. Have a nice day.